sir. Visible. Shall we start? Good afternoon, everyone. A warm welcome to all the participants to the sixth session of our AICT Atal Faculty Development Program on Industry 4.0. Today, uh, we are honored to have with us Dr. Shiv Manjaree Gopaliya, a distinguished academician and researcher who will be delivering a session on robotics and automation in smart factories. Dr. Shiv Gopaliya is currently serving as Assistant Professor and Program Chair, BTech Mechanical Engineering, AI and Robotics at the School of Mechanical Engineering, VIT Bhopal University. She holds a PhD in Robotics Engineering and MTech in Robotics and Automation, bringing over 17 years of rich experience in academia, research, and institutional administration. Her expertise spans robotics, mechatronics, intelligent control system, and Industry 4.0 applications. She has successfully led several government and industry-funded research projects in AI-based manufacturing and automation, and has also represented India in prestigious international events and project showcases. Dr. Shiv Manjaree Gopaliya has an impressive research profile with numerous publications in international journals and conferences, including recent contributions to robotic sustainability, motion retargeting, and neutral network based joint motion prediction as audit coordinator for NBA, NAC, and IQAC, and convener of the IPR cell at VIP Bhopal. She has made significant contributions toward academic quality, innovation, and intellectual property awareness. We are truly privileged to have her to share insights on how robotics and automation are transforming model smart factories under Industry 4.0. On behalf of the organizing team and all participants, I extend a very warm welcome to you, ma'am. Welcome, Dr. Shiv Manjaree Gopaliya. Ma'am, we request to kindly take over the session. Before we begin, I would like to remind all participants of a few quick points for smooth conduction of this session. Please mute your mic while this session is ongoing on, and ensure that you you must fill the feedback form and complete the assignment which will be shared on WhatsApp group after this session. So all the virtual platform is all yours, ma'am. Please, over to you, ma'am.
Yeah. A very good afternoon, and thank you, Dr. Sagre, for a wonderful introduction and for giving me this opportunity to be a part of your Atal FDP program today as a session expert. And I really look forward to this interaction where I hope that my expertise will, help to for a better understanding to the audience as well. I have one small request. I would request all my participants here to be ready with your mobile phones because we will be having an interactive session. Okay, so please be ready with your mobile phones, and then we will interact and we will proceed with the presentation. So just give me 1 second, and I hope my screen is visible, everyone. Please confirm whether my screen is visible or not.
Yes, ma'am.
Okay, I think my screen is visible and I am audible clearly just before I start with the session. Okay. So a very good afternoon, all of you, and thank you for calling me to this Atal-sponsored FDP on the very relevant topic of the present times, that is Industry 4.0, concepts, technologies, and implementation, being held under the supervision of Dr. Sagre and his team by the Mahavir Polytechnic, Nashik. And my today's topic is on robotics and automation in smart factories, the needs and challenges, and exploring the evolution, importance, and future directions. So I'm Dr. Shiv Gopaliya, and I will be talking today about the industrial revolution, why robots, how artificial intelligence is integral to robots, new domains of research, how robotics has performed so far, sustainability, robots in Indian scenario, needs and challenges, and we will summarize. So this will be, the total walkthrough of my today's presentation. Now, this is a very, simple yet relevant question, that what do you know about robots. Even before I start into the details, topic discussion and everything, I would like to tell you that my association with the term robot started way back somewhere in 2005 itself. So it's almost like 20 years now being discussing robots, learning robots, and it is a very, very developing domain. And in the present times, if you see, the application of robots have have no bounds, whether it is homes or industries, it has moved beyond industries, right? So let's explore the robots and the smart factories, as the topic says. So please be ready with your mobile phones, and here goes your very first question. Okay, I'll give you like 2 minutes. Please scan this code which is on the screen, and you have to answer that what is a robot, and in one word only. So I would like to see my participants that what idea you have about the robot. I hope my screen is visible and you are able to scan the QR code. What is a robot in one word? Let's have an interactive session, because one-way talking is so boring at times. Okay, so we have the first answer on the screen. Everyone, please participate. Okay, so it's a statement, is a machine that can do a task. So you have to answer in one word. That is the catch. Okay. So we have answers like beautiful, it's model. Okay, someone says beautiful also. So robot is beautiful. Well, this is a new insight. Okay, so robot is a robot. Okay, that answer is also there. It's design, it helps. And the most relevant answer that has come up is a machine. And I hope whoever participant was trying to give the full statement, the answer to it in one word could be, understood as machine itself. So yes, a robot is a machine. And if you ask me, and I must tell you that I'm a core mechanical engineer by my profession, by my studies. And yes, robot in the present times is the most technologically savvy, most advanced machine that is known to the humankind. Yes, so robot is a machine. Okay, so we have one more participant who is typing something. Let's wait for a few more seconds. Okay, advanced machine. Okay, so one word, it's a machine itself. Okay, so let's go ahead with our talk, and let me give you a brief history of the Industrial Revolution, because it's very important that when we talk about engineering and how it has progressed. So we all know that somewhere Industry 1.0, because Industry 4.0 we are sitting in the present time. So Industry 1.0, it started in the 18th century, where 18th century actually saw mechanization, the steam engine, the water power, All these things for the first time it came for the mankind. And then Industry 2.0 happened, where Industry 2.0 happened in 19th century. It saw the electricity generation, the mass production. For the first time, factories were there doing the mass production. Textile industry was huge. Then we had the assembly lines also, and everything came up in the 19th century itself. Industry 3.0, that came up in the 20th century, where there were a lot of advancements in the ICTs, electronics. Automation started in 20th century itself, networking, networked production. And here, before I proceed, I would like to say this, that it was in early in the 18th century, somewhere in 1865, where for the first time Massachusetts Institute of Technology, the MIT that we say in the present times, that came into existence. Okay, and only 15 students were there, with 5 students per stream, and only core 3 streams were there in engineering, that was civil engineering, electrical engineering, and mechanical engineering. So yes, and this is how everything started, right? So 18th century, but in 20th century we went on for automation and electronics and networking and everything, and then came Industry 4.0, that is today. And what we are seeing today is, we have robotics, advanced robotics, 3D printing, that is additive manufacturing. Today morning you had a session in additive manufacturing also. I was going through the schedule. And then we have Internet of Things. Artificial intelligence is so huge these days. We have the big data. So all these forms the Industry 4.0. But when I walk through this brief history of the Industrial Revolution, there is this pertinent question that, what is Industry 4.0? So it is the current trend of automation. Everything is like automation, whether we are having smart factories or smart homes or anything, it is automation. And when we say automation, the crucial fact is, that how are we, using the latest technologies. So we need the technologies to be, up to date, like cyber physical systems, Internet of Things, cloud computing, cognitive computing, everything. And whatever we are trying to do, we are actually making a very robust, laborious factory. Everything is getting converted into a smart factory just with the help of these technologies, and everything makes the Industry 4.0. Now Industry 4.0 has given us smart factories that is highly efficient, they are secure, they are connected. We get the flexible manufacturing. We know in the present times what is the competition in the market. To survive in the market, the lead time should be so less, and everything comes up with flexibility when we talk about in manufacturing senses. Then mass customization, this is crucial. Manufacture what customer wants with low incurred cost. Okay, so low incurred cost. And one thing more, that is, in the least available time, you have to give it to the customers. And then definitely the technology. So Industry 4.0 is made up of the technology. When I say technology, it means the interactive tools for the customized products. And it is applicable not only for the software, for the hardwares as well, and somewhere, the hardware and the software must work in, unity, and only then it will help the humankind. So this is very, very crucial. Now, if I look into my last 2 slides, there is this question that, what is common in industrial revolution? What is common? The common factor. If I look into the industrial revolution starting from Industry 3.0, Industry 4.0, and here I have taken the liberty to add one more term, that is Industry 5.0. I will be talking about this term a little later in the slides to come. So if I see what is common in these industrial revolutions, the answer to me is a robot. Definitely it's a robot, from 3.0 itself, where automation, started. semi automation, automation, that level, that progress, we have actually started going towards the robots itself. And definitely we have the best, robots like Sophia, best humanoid robots present in the present times. Yes. So I hope you will agree that the common factor in the industrial revolution is a robot itself. Well, this is a separate task that, how many of us, or how much of the younger generation is studying, or is learning about robotics, and how much they know how to work on the most advanced machine. That is a secondary question to answer. That will also come in my presentation in the slides to come. But this is very, very important, that the common factor is a robot itself. And then the question arises, why robots? So before I move on to the why robots, I would again take the liberty and I would ask you to please write just one application of robot that is known to you. Any one application of a robot. So you have time. Please answer to this. I hope participants are actively listening to the session. Name one application of robot. Autonomous vehicles, hazardous work. Repetitive work. Okay. Any other answer? Okay, so we have three participants who have answered this. Mm, okay, I think I should proceed ahead. So, what we see over here is, that one application of robot, and what everyone has tried to tell over here is, the which type of work we need a robot. Okay, so whether it is a repetitive work or a hazardous environment, and we want a robot in such conditions, autonomous vehicles in that way. So let me tell you the robots that we have over here. So we have the pick and place, pick and place type of the robot, the most elementary, even in the educational robots also, this was the very first time, pick and place robot. We have the loading, unloading robots. So that is the palletizing, the task that is done. Okay, then we have the spray painting robots. We have welding robots. Welding, that is the application when we talk about palletizing, spray painting, welding, cutting. Even in the present times also, if you go to any factory and if you see a semi automated factory, you will find that there will be one or two robots, for the sole purpose of welding or cutting or grinding or spray painting only. So one thing or the other, and we say it is a semi automated factory. Otherwise, we also have the fully automated factories as well. We have the inspection robots. So if I look into these applications of robots, what it turns up is, we are actually doing smart manufacturing. These are all related to smart manufacturing. So we have smart manufacturing, whether it is semi smart or fully smart. That is again, question based upon the level of investment, that initial investment that goes into this. Now the question arises, that are robots limited to industries only? Anyone who would like to um, and speak up, you can unmute yourself and you can say, are robots limited to industries only? Anyone? No answer? I hope I am audible to everyone. Yes? Well, this is a boon and a bane in the online, lecture also. But yeah, so let me proceed with, are robots limited to industries only? So the answer is definitely no. Okay, and why? How this has happened? Because the application areas have changed drastically. So if you look into the robots, we have the industrial robots. My last slide, it talked about all the industrial robotic applications, whether it was welding or spray painting or grinding or cutting or anything. But then we also have surgical robots. These days surgeries, invasive surgeries are performed with the help of robots and cobots. Collaborative robots are also there. Then we are having the entertainment based robots. This dog that you see over here, it is a Sony, company which has made a Sony Aibo, and that is the name of the dog that we have. We have robonauts, we have service robots. There are so many hospitality industries that has come up with the service robots, and definitely defense sector has explored, is still exploring a lot of potential of robotics and how to use and bring robotics into the defense line. So yes, and apart from this, the application of robots go into, we have the manipulators, like arm like of a structure. We have legged robots, we have wheeled robots, we have underwater robotics, and there are, academics, universities where the underwater robotics have taken a lot of, strength also. We also have aerial robots. The best example is the drones that we have, right? And if I talk about that, why, with all this thing, why the robots are preferred, so it can be best answered if we can, just sit and we analyze the pre-COVID times and the post-COVID times. So if I talk about the pre-COVID times, there the answer comes, which I asked, initially, that name one application of robot. So there it comes, whether you have the repetitive jobs, or you have the dangerous or the hazardous jobs, or if you have the menial jobs. The last one is a scrub mate. That is the name of the robot, that was developed for scavenging purposes and everything. Even in the present times, few places, for scavenging, these robots are being used. So yes, this was the era of the pre-COVID, and this was also one of the major reason why robots were, treated only for the industrial purposes. As soon as the term robot comes into the picture, and one will think, that okay, it is only limited to, industries. But that is not the scenario, in the present time. So how it has changed? So COVID was very harsh. COVID was very tough. That whole phase was very tough. But if we talk about the technology, it has changed also. And we have seen, during these tough times, there have been patient monitoring robots. We have delivery robots, because everyone was like bound to, we were into isolation and everything. So delivery robots and security robots, and definitely smart homes. So yes, and if I talk about smart homes or delivery robots or something, these are a level of automation. And when you give a level of automation, the robotics, the robots are ready to listen to you and answer to you. So post COVID times, robots have moved beyond the industries. Okay, so they are not only limited to industrial environment. And then there is this very basic question that, how is it even possible that, the areas where we were not even thinking about, and now the robots are ready, to be used. And even I would say that the way the startups are coming up, the way the market is growing, the application areas which we are not even thinking, on a daily our daily basis, there might be a company growing, where you can find a robot serving humankind in some other possible ways. And then the question arises that how this shift has actually happened from the post COVID COVID and the pre-COVID, pre-COVID era to the post-COVID era. So it has happened, the answer is the artificial intelligence. And we know, the drain that has gone, in the younger generation towards the artificial intelligence. But then as mechanical engineer myself, I must tell you that, AI is very, very good, is very, very strong. But AI, when it goes along with the robots, that is the best machines, the scope goes beyond also. Okay, so when you learn AI, let's learn AI with robotics. That gives the extra edge. Now the question arises that how AI has become, integral to robots and how it is. So AI, is the brain. It is the artificial intelligence. We are trying to give the thinking capabilities to the machines in the very layman terms, and that is only possible when your machine will start thinking like humans, and humans think based upon their sensory perceptions, based on our five sensory perceptions. So we should have the visual perception, the speech recognition, the decision making, and the language, if you are able to remove the language barrier as well. So if mathematically, computationally, if we are able to handle, we are ready to develop such models, that is artificial intelligence. Now, if I talk about the connection, so the highest level of autonomy that you can give to a robot, it comes through AI only, because AI will work as the brain, but the body is definitely the mechatronics. So it is not pure mechanical engineering also, because in the last many years, mechanical has grown into mechatronics. That is how we talk about the full automation, or a semi automation and everything. So mechatronics, so electronics and mechanical, so that is how it becomes the body and AI becomes the brain over there. Okay. Now, if I talk about the mechatronics, you please go through the mechanical when we talk and the robots when we talk. We have the industrial robotics, kinematics. I think someone has, if someone can mute yourself, organizers, if you can see. Yeah, thank you. So we have kinematics, we have dynamics, we have degrees of freedom, trajectory planning. These terms, motion planning, applications, additive manufacturing, huge list. Okay, and then we have, when we talk about mechanical, well, yes, these are the mechanical parts. Then electronics, that is the instrumentation and controls and electronics. We have the types of controllers, the supervisory control, collision or the obstacle avoidance, cybernetics, adaptive control, the feedback loop, the Kalman filters, all these things, these becomes the mechatronics. This is the area of the research that, you can take your direction into. However, when I talk about the artificial intelligence, that is the brain, you have the various AI techniques, swarm intelligence, PSOs, hybrid techniques. These days, we don't go with only one type of AI technique, but hybrid, because we try to get the, best advantages, the positive potentials we have to utilize, and we have to develop the models. Okay, so that the error-prone nature, is minimized. And cognitive science, deep learning, big data, all these, all these are the parts of development of the brain. So we know when we talk about robots, so this is what a robot is. So robot is not working without the AI. So definitely we have the robots and we have the AI also, the body and the brain, this information. And then there is this question that how robotics has performed in research. Research is so important. We are, after all, we are academicians, and it is on us that the fundamentals of this best machine should be taught in the right ways. But I will come to this particular question a little later in my slide. I would rather move ahead with a little more toward the manufacturing systems in Industry 4.0. So if we look into Industry 4.0 in the present times, you see it is we talk about the sensors, the tools, the automation, the safety, the quality of the product. Okay, the industrial apps, everything is networked, and industrial IoT. IoT is Internet of Things. I do remember when for the first time we heard this term, like Internet of Things. And interestingly, it is like anything, you use anything, and then we are using manufacturing systems. So IoT has a new name, that is Internet of Manufacturing Things. And it actually helps us to bind the whole manufacturing arena into one place, that is the architecture, with real time traceability. So there are these very uh, thumb rules on the most important parts, like real time applications, adaptive controls, visibility. And unless and until anything is visible to us, we cannot relate to those technologies. So that is also very, very important. So optimization of manufacturing systems. So you see, IoT is a technology, and it is so relevant to Industry 4.0, because it helps you to network each and everything together. Okay, and then I have already talked about the cyber physical system, cyber security, the big data, the data analytics. And here I put up a very important question, that when we are talking about the big data, where is the data? What is the data? And what data are we talking about? So the question is very, simple and very basic, but then it is also on us that we need to explain the data is, you need a machine which is involved with so many sensors. The sensors are producing data. That is, data means what? Sensor, there is a temperature sensor, there is a pressure sensor, there is a position sensor. Multiple sensors are there, and this is the data, some values, and this data is coming up per second. So you can see the quantity, the TB of the data that goes into. And as researchers, as industrialists, as industry person, or as an academician, this is the data that we explore. Okay, that is the data on which we apply different artificial intelligence techniques, and the reason is to improve the efficiency of the machine. So everything goes back to the machine itself. So we started from the machine produced the data was analyzed, okay, the models were created, optimization was done. Now all this thing in between goes, multiple technologies in the forms of monitoring tools, or automation, networking, or Internet of Things, or anything you talk about. And then end of the day, we are optimizing and increasing the efficiency of the machine, meaning we are increasing the efficiency of the factory, meaning we are going to increase the productivity of the factory. At last, we are actually talking about the cost. We are making profits because the efficiency has increased. So when we are making the profits, there is a very simple proverb, that time is money. So in the least time, how efficiently we have improved the efficiency of the machine. But somehow, if I look into the present scenario, we have somewhere we don't talk about the machine. We talk about all the technology, we talk about all the modeling, we talk about all the optimization, but each and everything is related to machine. Somewhere we forget that term itself. So as an academician, it is very important to let our younger generations also know that everything is related to production only, because factory has been set up with the mindset, with the very important objective of making a profit will only come when you will make the product, and product should be made and it should be sold off also. That is also very important. So Industry 4.0, it is very, very crucial that we should learn the advantages and disadvantages of machines, along with all type of technologies that are present. Okay, so let's move ahead with this, and let me give you a little more, insight into what I mean when I say Internet of Things into the manufacturing system. So we have this IoT MS, and this is, how your one factory layout will look like. So if I go through the lowest step, and if I rise onto my stair like this, we have the factories that are the manufacturing resources. We apply all the IoT techniques, whether it is sensors connected, because that data, that TB of data, we cannot store it in a pen drive or a hard disk or something. So definitely all the data is being stored in the cloud. Okay, when I'm saying cloud, so there was the picture of cloud computing. When you say that all the major data is getting saved on the cloud, you know what happens? There comes the picture of, please mute yourself. Please mute yourself. Thank you. So when the data goes onto the cloud, it is also very, very important to safeguard your own data. There goes the picture of cyber security, cyber crime and all those things. And then we have, the smart stations, real time optimization. And this is the real picture of the Indian factories when we are sitting in the Industry 4.0 era right now. Okay. And this is how, the whole factory is behaving, is working in the smart environment. Okay, so moving ahead, there is this question that how Industry 4.0 actually affects us. So you see, cloud computing, cybersecurity, AI, IoT, I have already talked about this. And then you see we have additive manufacturing, augmented reality. If we have so much, there are courses also, like VR, AR, VR and all these things, big data, advanced robotics. And now, if I show you this whole picture of Industry 4.0 technologies, you will find that robotics has also become just one component of the whole Industry 4.0 technology. And it is not just anything, it is a machine. So, machine, along with all these technologies, will only help us to move ahead, in the time to come. And then if I go through this ladder from Industry 1.0 till Industry 4.0, let me go to the Industry 5.0 also. So before that, Industry 4.0, moving on to Industry 5.0. So we are sitting in the 21st century India in Industry 4.0. And I must tell you that the developed countries, they are already working, towards Industry 5.0. So 5.0 is the place where, the work is going alongside the robots and the smart machines. Because you see, unfortunately, this is also the era where we have seen a lot of unemployment. This is how the debates come up when the robots, this term is put up. But, it has come up with the unemployment. Well, I would rather say reskilling and skills labor and something. But it has also made the point very relevant that, humans must work alongside the machines. Okay, and this is the research shift, this is the industrial shift that is going on, at least more than a decade now in the developed countries. Okay, where humans and robots can work together, and this is called as Industry 5.0. So the younger generations, when they will graduate and they will move towards their post graduation, their PhDs and everything, so definitely Industry 5.0 will be more relevant, more futuristic when we are talking about. And how is this possible? Because you see, robots are helping the humans to work in a better way, in a faster way, with the best technologies. So, yes, we have to reskill ourselves with the best technologies that are available in the market in the present times. We have to keep ourselves up to date. Okay. And Same time, we have to utilize the potential of the robot as well as the human. We cannot simply replace both. So somewhere we have to put that, that optimization of a machine and a human to work together. And this is industry 5.0 when I'm talking about. And when I say so, it is not possible if you do not talk about sustainability. So then the question arises that, what is a sustainability as a concept, as an approach? So concept is very simple, sustainability in present times in academics also, a lot of effort is being put up, even by the government and by the universities to put up sustainability, and to make the younger generations know what sustainability is all about. So yes, somewhere we have already hurt the ecosystem, the environment, and this is the right time, to create the right balance between the environment, the society, and definitely the money, the economics. Okay, and when we will be able to make these three balanced, the output will be the most sustainable one. So this is a concept, this is the fundamental. And then in order to achieve it, we have the sustainable development goals given by the United Nations. So we have this, and there are industries working in this direction. There are so many, whether academics or industries or startups or people, individuals, they are working, in such engagements, so that, the products go sustainable. And while I'm talking on the slide, I must say this, that just because you have painted a product green does not make it sustainable. Okay, so technically, your product needs to be sustainable. The output should be sustainable. So that is very, very important. Moving ahead, it is also very important to know that what is the role of robots, or the status of robots in the Indian scenario. Because India is going through, because we know, we have the Make in India plan. We know how much manufacturing units are coming up in India, and what role someone is
Hello.
someone is trying to say something. Thank you. So robots in the Indian scenario is also, very, very crucial. So we have the industries, how, Indian industries are behaving. So we have fully automated industries, we have semi-automated industries. Then academia in the present times has taken, a lot of, relevance in going ahead with robotics. Universities of national importance, private universities. I belong to VIT Bhopal University. We have program like robotics and artificial intelligence. This is also, important for us, that when we are making our younger generations tech savvy and industry ready, when we say they are going industry ready, so it is also very important that they learn the latest, requirements of the industries. We have colleges, schools have taken this responsibility, and they also have very wonderful, robot labs if you go to the schools. So academia has also taken, the importance of robots, and the Indian scenario is changing. And definitely the startups, the younger brains, the younger minds, they are so sharp, they are so, they are ready to dream and believe in their dreams. And we have the startups, so upscale growth to become the full-fledged industries. And then there are, economic supports also, and definitely from small startups to the big dreams. So this is the whole, scenario presently, how it is working, and the progress is good if we look into. Yet a lot of work needs to be done when we say robotics and artificial intelligence. So there are many areas to explore and work together. Now the question arises that, what does a robot do as far as, the Indian factories are there? So definitely industry 4.0 already. Now what industry 4.0 is, I have already told you about this. But then the question arises that, What will be the future? Well, industries are already there with the robots. Robots are coming up with their brain, that is the AI. So the future depends upon the size of robots. And this is the crucial factor which has come up post COVID times. The size of robot has changed. Now, when I say size of robots have changed, we have these collaborative robots. Okay, you see, there is this one body only, but with two hands. So it is like, a human is standing on a platform, and it is doing a task, in tandem, in unity. So that is important. So we have the collaborative robots. So you see the whole shape, size, picture, everything of the robot has changed. Then we have, these like micro robots and the nano robots. Okay, and robots are these days, they are infused into the bloodstream also, and then they do the invasive surgeries. And this is, how the robotics have progressed. So healthcare industries, automotive industries, 99% of the sensors are used in automotive industries. And one thing that goes behind the automotive industries is the MEMS industry, that is the micro electromechanical systems industries, where, the micro level sensors, nano level sensors are there. Defense sectors, where the bugs are created as surveillance. So the answer, the futuristic approach goes into size of robots also. However, mechanically speaking, again, the kinematics, dynamics, controls will always be there. But then the size of robots will vary, is varying, will vary, and how, our younger generations are going to learn and cope up with this is very important. So we have to train them in these directions. And when I talk about, that let's make the industry 4.0 ready for our younger generations, we also need to acknowledge the most important part, that what are the needs and what are the challenges. Robotics is just not a course. Okay, so how to move ahead? So the challenges are the market challenges, the human robo interaction is also a part of, industry 5.0, a common machine language. Okay, because we know that every 6 months the softwares also keep changing, keep updating. And improved cyber security, because all your data is there in the cyberspace. So yes, we have to go with the cyber security. However, with these challenges, the Indian industries are working really great, but then also remains the needs of the Indian industries. And we have seen the gradual progression from semi automation to fully automation, making the factories smart factories. And we need robotics engineers. So, somewhere as academicians, it is very important, that we look into the importance of multidisciplinary engineers. We keep saying that, when the industries come for placements or something, they do look for interdisciplinary engineers. And this is important, qualified multidisciplinary engineers. Here I will take the liberty to say robotics engineers, because along with all the streams, you need to know your machine also. So it is good that if you are, progressing towards robotics, the need of the hour. And definitely the skilled labors. We need to reskill ourselves, and we need the skilled labors. Now, future of robotics, if I talk about, the factories that will come up, will mostly, be autonomous, be fully, robotic based. And you see how the inspections have changed, the smart mechanical systems. So everywhere, we have an Alexa at home. You see, you speak, you talk, and you work. So everything is there, voice recognition. We talk to our TV screens, we talk to our laptops, we talk to Alexa, so the factories of future, the 40 years ago, whatever was there, gradual progression is there. And interestingly, our society is ready to, take all the changes. We are ready to adapt to all the changes also. So this is how the factories of future are going to look like. So here I would like to conclude, but before concluding, let me go back to my very initial question which I left earlier, that how it has progressed as far as research work is concerned. So my research has progressed since 2005, and 20 years. A lot of my domains have also changed. So I'll keep talking about this, but then you know uh, about my research, you have the pick and place robot, you have the this is more like a surgical robot. And I have worked on the kinematics, dynamics, software tool development. So if you are the researcher looking into, you go with the development phase. Development is more important when we are talking about. So yes, experimental validation, we are mechanical people, we know how much experimental validation is important. My students, when they come and say that they have made some virtual, some softwares or something, my very first question to them is that whether your software will work with my machine or not. Okay, because finally I have to develop a product out of it. I have to manufacture a product. So whether the software is reliant with the machine, whether that collaboration is possible or not, that is very important for the younger students to learn and to do. So trajectory, well, yes, this is just a part of like kinematic modeling, how it is done, the details, of when I say kinematic, we have the forward and the inverse kinematics, the trajectory planning. And then this is important, if I give a trajectory, how is this going to work with? And if you look into how much error is there, and how much error is acceptable, and how whether or not the results that you have procured can actually be put into any industry or not. And then yes, dynamic modeling is important. And if you look into my research for the last 20 years, my students have also worked in the directions where we have gone into sustainability, energy saving, and rehabilitation robots, and prediction analysis. So you can even visit my Google Scholar page, and you can look into the type of the work that me and my students have been carrying out in the present times, over the years. And this is very important to make yourself industry 5.0 relevant also. Okay, so before I conclude, I would request all of you to please scan this QR code, and you will find a set of quiz questions. You please answer it. I will give you like 10 minutes. I hope people are there.
Let's start. लोक भरतील एवढं लोक भरतील.
Organizer, if you can just confirm me.
मेल आय डी पण जातो.
Dr. Sagare or Mr. Sonmani, if anyone is there.
Yes, ma'am.
Yeah, I hope the participants are taking up the quiz, if you can confirm. And in this time, if they have any doubt, also they can ask me the questions. If I'm open for the questions also.
Okay, okay. Dear participants, please, if you have any doubt, you may ask to Dr. Shiv Manjaree Gopaliya.
I think the participants are taking up the questions. I can share the, later on I can share the responses that they have sent.
Yes, ma'am. You can share the link of this quiz to us. We will send them on WhatsApp group.
Okay, even that can be done. Just give me 1 second. I will. To Mr. Sonwane, I have shared the form link. I'm also sharing it on this messaging group. Okay, just give me 1 second. Acha, people were typing. Okay, so instead of the QR code, few of them have typed in the messages link. So I have given it, the link on the message on the chat box. You please open that form. And Prasanna Sekar sir, he has raised hand. Yes, what is the question?
Prasanna sir, you may unmute your mic and ask to Dr. Shiv Manjaree Gopaliya.
What is your question, sir?
Prasanna sir, if you are unable to ask, you may type in chat box also. तुम्ही सर प्रसन्नला unmute करते तर बरोबर.
Okay, I think there is no question.
Ma'am, I think no participant have any query or doubt.
Okay, so Mr. Abra Mukhopadhyay has written, kindly share the QR. Just above your message, I have also shared the Google Form link. It is the same, form link or the QR. You can access the Google Form through that form link. So you please access the quiz and write the quiz. Okay. So, Dr. Sagre, I am here itself. If there is any question or anything, I am open to the discussions. Okay, and let the participants also write the quiz. There are around 50 questions, so they will need some time to answer it. Jayant is trying to say something. You are not audible. Please unmute yourself.
And there
Okay,
is
so
a question
yes,
that
yes. Yes, Dr. Sagre, I just saw this message. Thank you for posting this message here. How will teach students in a simple way about robotics? Um, Sir, I have already said that schools have also taken the initiative and they have opened the robotics lab, and and as an extra course or something they are also teaching robotics. And one of the uh, things is for example, in my university, VIT Bhopal University, right now we also have a program, dedicated program under the School of Mechanical Engineering itself, which is the mechanical engineering in AI and robotics. Okay, so yes, you can come up with new programs. Even you can come up with courses or nothing else, events also, like robo wars or some robotic events can also help the students to think beyond their limits, and then they can develop. You can take up in-house projects also, and you can work in those directions. Definitely expertise will be needed, but somewhere people need to start. And yes, it is robotics is also one stream that needs a lot of patience also. Patience in the sense, immediately you might not be able to see the outcome, but if the students, they are working in team, year wise team, and they're working on a project, students will learn more about robotics in that way. That is my take on it. Apart from that, we have so many courses. You can study the courses, you can learn it, you can score well, and you can do. But my perception of robotics is not only software based. So somewhere, your students should develop a robot in their lab or something, and then they code, and then they collaborate, and then their hardware should work along with the software, so that interactive way. So that will be better if you don't have a course or a program, dedicated program for that. I hope I have answered your question, Ganesh sir. Any other question?
course.
Can you suggest any course? Well, we have courses on if you go through the NPTEL, or so there are so many courses related to robotics, advanced robotics, and rather I would say that even before you turn up into robotics, you please go through the prerequisite courses like instrumentation and control, and mechatronics. Keeping in mind that you are a core mechanical engineer, so definitely you will have a better understanding towards automation and how to proceed further. And then there are so many online and offline platforms where courses related to robotics, controls, mechatronics, dynamics, these are already there. So start with the introductory, go up to the advanced level. Okay. Thank you, Ganesh sir, for your kind words. And I'm open to any further questions. I hope the quiz is simple to answer. Yes, the quiz is very long, but it talks about everything related to Industry 4.0. So I think you will get an insight, a better insight of what we have talked today. Yes, regarding the PPT, I will be sharing. I think I have shared the PPT with Dr. Sagre. If not, I will be sharing it once again uh, to be shared with all of you. Yes.
Karo conclude. Dear participants, please, if you have any query, please ask to Dr. Shiv Manjaree Gopaliya. Ma'am, I think no participant have any doubt or query. So shall we conclude this session?
Yes, okay. If there are no further queries, and I have only received one response to the quiz, I hope the others are already participating and they will, there is, I have not kept a time limit as of now, but you please, submit the responses. So I would request all the participants. And yes, with your permission, we can come towards the conclusion of this session.
Okay, ma'am.
Over to you.
With your permission, we conclude this session. So thank you so much, ma'am, for such an insightful and informative session on robotics and automation in smart factories. Your presentation has truly helped us understand how automation and robotics are shaping the future of Industry 4.0. The way you explain the practical aspects and real world applications was extremely engaging and enlightening. On behalf of the Mahavir Polytechnic, Nashik, and all the participants, I sincerely thank you, Dr. Shiv Manjaree Gopaliya, for taking the time to share your expertise with us today. I would also like to thank all the participants for their active involvement and for making this session interactive and meaningful. So thank you so much, ma'am.
Thank you, Dr. Sagre, and thank you, Mahavir Polytechnic, Nashik, for calling me on this platform. It was wonderful interacting with all of you. Thank you once again.
Dear participants, please ensure that you have filled the feedback form. If not filled, we will share the feedback link in WhatsApp group. Also, we will share in chat box. So ensure that you have submitted feedback form and assignment also. So we conclude this session, and the next session will be on tomorrow morning at 11 a.m. So thank you so much. Both recording.